Hello, today in advanced chemistry, we are reviewing dilution math and basics of titration equations. So let's begin with dilution. Dilution is when you take a concentrated solution and dilute it down to where there are fewer solute particles in relation to the solvent particles. We generally call those concentrated solutions that we keep in the stock room stock solutions. It's just more economical to buy a really concentrated bottle of like 12 molar sulfuric acid or hydrochloric acid and store it in the stock room and then dilute it down to the concentrations that are needed in lab because it's a lot cheaper to do that and it will last you a lot longer. Plus it's going to take up less storage space in the stock room. So there's two versions of this equation. I frequently will use MC times VC equals MD times VD. The C's stand for concentrated, so molarity of concentrated times volume of concentrated equals molarity of dilute times volume of dilute. And the reason why this works is because molarity times volume will tell you how many moles you have. So when you take a concentrated solution and you dilute it down with water, you are never changing the number of moles of solute. You're just adding or removing moles of solvent to the solution. So the moles of concentrated solution should always be equal to the moles of diluted solution. The textbook gives you this more generic version of the equation, M1V1 equals M2V2. That way you don't have to worry about what's concentrated or what's diluted. I don't really care which one you use. I boxed in this equation because you can add it to your equation sheet that we are keeping track of for you to use on quizzes and tests. The main thing is that the units must agree. In the last lesson, we were talking about when you calculate molarity, that molarity is moles per liter. You don't have to use liters in this equation. As long as both volumes are in milliliters, that's fine. Or as long as both are in liters, that's fine. What you cannot do is have one volume in liters and one in milliliters and expect it to work out. So let's take a look at sample problem number 7 from your chapter 4 sample set. It says, to what volume in milliliters should you dilute 100 milliliters of a 5 molar CaCl2 solution to obtain a 0.75 molar CaCl2 solution? So I am going to write down that the first number that we are given is 100 milliliters. I am going to label that as a volume because it is a volume, and I'm going to call it V1. Now, they also tell us that the molarity of that solution is 5.00 molar. I'm going to call that M1 because it goes with V1. They then give us a second molarity, so I'm going to call that M2 of 0.750 molar, and we do not know what the volume is for that constant or for that solution. So I'm going to call that V2 and say that that is unknown. So I'm going to rewrite my equation that we were just talking about. M1V1 equals M2 V2. And I'm going to circle that I want to know V2. So I've got to get V2 by itself on the right side of the equation. In order to do that, I'm going to have to divide by M2. And what you do to one side of the equation, you have to do to the other. So my M2 is going to cancel out. And if I rewrite this, then that's going to say my second volume, or V2, is going to be equal to M1 times V1 over M2. So now I can plug in values. M1 was 5.00 molar. V1 was 100 milliliters. And M2 was 0.750 molar. Now, if I look unit-wise, molarities are going to cancel, and that's going to leave me with an answer in milliliters, which is good because that's what they were asking me for. So when I plug this into my calculator, I'm going to do the numerator first, 5 times 100, which is 500. Then I'm going to divide by the 0.75, and I get 667 milliliters would be the volume that you would need to dilute that to. All right, next, let's review the steps to solving a titration problem. The first step in solving any titration problem is to write a balanced chemical equation. The second step is to determine the moles of known by taking your molarity times liters, and it is important that this does have to be in liters. You cannot use milliliters for this. Next, you are going to convert moles of known into moles of unknown, and you do this by using stoichiometry and the balanced equation, like what we did in chemistry 1. And the last step then is that you are going to use the moles of unknown that you just found in step 4 and the given information to find whatever they're asking you for. Sometimes they'll ask you for the molarity of the unknown, sometimes they'll ask you for the volume. For those of you that are at home on remote learning right now, I did allow my students to make a note card of these steps. Feel free to write that on a note card if you have one. If you don't, I can give you a blank note card when you get back and you can make this note card for yourself. All right, so with that in mind, let's take a look at sample problem number 8. Sample problem number 8 says, what volume in liters of 0.15 molar KCl solution will completely react with 0.15 liters of 0.175 molar PbNO3 solution according to the following? All right. So if I go up here to my steps, the first step said I should write a balanced equation. Well, they already gave us a balanced equation, so we're good to go on that. Step 2 says, oh, I guess I forgot that when we were going through our list. My apologies. It says that we should list all given information, and we should identify the known, both molarity and volume is given for the known, as well as the unknown. The unknown is the substance where they only tell you either molarity or volume. All right, so what I'm gonna do now is I'm gonna do step 2. I'm gonna list everything they tell me. So for KCl in the problem, they tell me that my molarity is 0.150 molar. They do not tell me what the volume is of KCl. Lead to nitrate, on the other hand, they tell me has a concentration of 0.175 molar, and it has a volume of 0.150 liters. So that means that I'm going to label lead to nitrate as my known because I know both the molarity and the volume of that. I am going to label my KCl as the unknown. All right, and for the reason why I call that the unknown is because I know the molarity, but I do not know the volume. Okay, so let's go back and check our steps. Step 1, we already wrote the balanced equation. Step 2, we listed all the information that they gave us and we identified the known as well as the unknown. Now, step 3 says to determine the number of moles of known by taking molarity times liters. So, my known, I said, was lead to nitrate. So I'm going to find the moles of PbNO3 by taking the molarity, which is 0.175 molar, times liters. And in this case, they already gave us the volume in liters. A lot of times they might give it to you in milliliters, so you would have to change to liters. So they said there's 0.150 liters. So I'm going to take 0.175 times 0.15, and that is going to tell me that I have 0.02625, and my unit label is moles of PbNO3. All right, so I now have determined the moles of known because I said lead to nitrate was my known. Step 4 says that I'm supposed to convert moles of known into moles of unknown using stoichiometry and the balanced equation. So what I'm going to do now, let me change colors, is I am going to get rid of moles of PbNO3 because that's my moles of known, and I want to go to moles of unknown. So we had said that the unknown here was KCl. All right, anytime you go moles to moles, you have to take a look at the coefficients in the balanced equation. When I go back and look at the balanced equation, there's a 2 in front of the KCl and a 1 in front of the lead 2 nitrate. So now I'm gonna take my 0.02625 and I'm gonna multiply it by 2. That is going to tell me that I have 0.0525 moles of KCl. All right, but the problem is asking what volume in liters would I need. So number 5 on my steps says to use the moles of the unknown that I just found and the given information to find either molarity or volume of the known. So if we think back to our pie chart of molarity, molarity is moles per liter. So if I want to know liters, I'm going to cover up liters in the pie chart. When I cover up liters, the pie chart says I should take moles over molarity. So the liters of KCl should be equal to my moles of KCl, which is what I just found, 0.0525 moles of KCl, divided by my molarity, which they gave us at the beginning of the problem. Excuse me, it should be over here. I want to make sure I use the molarity of KCl, which was 0.150 molar. Okay, so I'm going to take 0.0525 divided by 0.150, and I get 0.35 liters of KCl as my answer. All right, so our takeaways from today's lesson, you have to start with the balanced equation, then you list all the information that they give you. You are gonna need your volumes to be in liters for your titration math to work out. In a dilution situation though, the equation can have milliliters entered into it as long as both volumes are in milliliters.